This is the lecture for section 1.2 for Math 163. In this section, we'll be talking about what we can learn from the graph of a function. Okay, so going back to the definition of a function, in order to tell if a graph represents a function, what we can do is called the vertical line test. And this says that a graph represents a function if every vertical line you draw intersects the graph at most one time, or at most once. Okay, so to test this out, I can draw a bunch of vertical lines on my graph here, and each and every vertical line that I draw should cross my graph at most one time if I am looking at a function. So this vertical line crosses here, this one crosses here, this one crosses here, this one crosses here. Even if I draw a line way over here, I am still crossing the graph of the function up here only one time. So for the first one, you can say that this is a function because it does pass the vertical line test. Okay, same thing with this one. Draw your vertical lines. You can definitely draw more of them, but I think just from this one you can see that it does pass the vertical line test because each vertical line that I draw crosses the graph at most one time. Okay, here are some other graphs, same thing. If we do the vertical line test, on this one, if I draw a vertical line here, you can see that it crosses twice, so this does not pass the vertical line test, so this one is not a function. Okay, on this one, draw a vertical line. Here again, it crosses twice, so this one is also not a function. Okay, some other things that we can learn from the graph. This is just reading points off the graph, basically. So for the first question, part A here, looking at this graph, what are f of 0, f of 3 pi over 2, and f of 3 pi? So this is asking three separate questions. The first one, f of 0, this says find the x value of 0 and write down the y value that goes with it. Okay, so find 0 on the x-axis, that's here, and then go up or down until you hit the graph. So that's at this point, 0, 4. So f of 0 is equal to 4. That's the y value at the x value of 0. Okay, next one, f of 3 pi over 2. Go to 3 pi over 2 on the x-axis. That's this point. The y value of that point is 0. So f of 3 pi over 2 equals 0. Okay, then the last one, f of 3 pi. Find 3 pi on the x-axis. Go up or down until you hit the graph. So that's this point here. So f of 3 pi is negative 4. Or negative 4 is the y value that corresponds to an x value of 3 pi. Okay, so now for part B, looking at the graph in its entirety, what is the domain of f? That means what x values can it have? Well, it starts here at 0. There's no arrow on the end of this, so this is a starting point. And then it's continuous until you get to 4 pi, and that's where it stops. So remember, for domain, we are naming x values, not points, but just the x values. So the domain is from, here, let me do a hard bracket there, from 0 up to 4 pi. And I did do hard brackets on those because there are points at 0 and 4 pi. Okay, what is the range of f? That means what y values can the graph take? So if I read the graph from bottom to top, the lowest y value that I see here is negative 4. Again, the graph is continuous, so it takes all the y values up until the y value of positive 4. So this range would be from negative 4 up to positive 4. Again, hard brackets because those y values are both included. All right, part D, list the intercepts. This means where the graph crosses the axis. So we'll start with the x-intercepts. That means where the graph crosses the x-axis. So there are a bunch of those. Here, 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 and here. So pi over 2, 0, 3 pi over 2, 0. It's anywhere there's a y value of 0. 5 pi over 2, 0. And then the last one is 7 pi over 2, 0. Okay, finally the y-intercept. There is only one of these, and that is where the graph crosses the y-axis. That's the point 0, 4. Or another way to look at that is where the x value is 0. Okay, so several things you can learn from a graph. X and y values, domain, range, and then your intercepts, x and y intercepts. Okay, same graph, just continuing the questions that go with it. Part E, how often does the line y equals 2 intersect the graph? Okay, so the line y equals 2 is going to be a horizontal line up at the y value of 2. How many times does that cross? 1, 2, 3, 4 times. Okay, part F, for what values of x does f of x equal negative 4? What is this asking? So f of x equals negative 4, that means where does the y value equal negative 4? So that would be here and here. The x values that go with those would be pi, 3 pi. All right, for what values of x is f of x greater than 0? That means where is your y value greater than 0? So that would be anywhere above the y-axis. So that's here, and all of this, and all of this. And it does say for what values of x. So we want to list this in terms of x values. So the x values for the first section is from 0 to pi over 2. It's above the y-axis. I'm just going to use parentheses on this. And then from the x value 3 pi over 2 all the way until you get to 5 pi over 2. And then from 7 pi over 2 up to 4 pi. Okay, so these are not ordered pairs. They are x values, right? Like written like domain, like an interval notation. All right, for the next one, consider the function f of x equals x over x plus 1. This says is the point 1, 1/2 on the graph of f. So the way to figure that out is just to plug it in. So we'll plug in our x value and see what we get as the y value. Okay, so if I do f of 1, this is going to be 1 over 1 plus 1, so 1 over 2, which does match the y value that they gave. So yes, the point 1, 1/2 is on the graph of f. Okay, part B, if x equals 2, what is f of x? So if x equals 2, I need to plug it in again. So f of 2 is 2 over 2 plus 1, so 2/3. And then it's also asking what point is on the graph of f, so that is the point 2, 2/3. So what we plug in is the x value, what we got out was the y value. All right, part C, if f of x equals 2, so that's asking if y equals 2, what is the x value? So here, if I plug in 2 where I see f of x, that'll be over here on the left side of the equation. Then I need to solve this for x plus I'm sorry, solve this for x. So to do that, I'm going to cross multiply. Think of this as being all together, and multiply both sides by x plus 1. So this will be left-hand side 2 times x plus 1, and right side just x. Okay, do some algebra here, so distribute the 2, and then solve this. So I get x equals -2. Okay, again, it asks what point is on the graph of f. Be careful here, we do still list the x value first, even though it's what we were looking for. So my x value is -2. The y value is what I started with, that +2. All right, the final question asks for x-intercepts and domain. To find the x-intercept, we want to look for where the y value is equal to 0. So plug in 0 where you see f of x, and solve this. When is this equal to 0? Well, cross multiply again. Anything times 0 is still 0. So you just get 0 equals x. Okay, so that would be the x-intercept is the point 0, 0. And then it's asking about domain. If you remember from the previous section, to find the domain, when you have a fraction, you want to make sure your denominator is not equal to 0. So I'm going to do x plus 1 not equal to 0. Okay, so I get that x is not allowed to be equal to -1. If you did have x equals -1, that will make your whole function undefined because it would be dividing by 0. All right, for the next question, you're simply going to use your calculator. The average cost C of manufacturing X computers per day is given by the function blah, blah, blah. Determine the average cost of manufacturing these different numbers of computers. So we'll just do the first part. A is 30 computers in a day. So it's X computers per day. So the 30 is an X value. You're just going to replace X with 30. So C of 30, just plug in 30 everywhere you see X. And then you'll just use your calculator to work it out. Okay, so let me take a second and type this in. You do the same. And let's see, I got 1,351 point, let's see, this is a cost, so I'll round it like money, so 54. Okay, so the average cost of manufacturing X computers, so 30 computers in a day, is $1,351.54. And so this is just using your calculator. For part B, plug in 40. For part C, plug in 50. Same. All right, just some review questions now. Determine whether the graph is that of a function. To do this, you should do the vertical line test. This graph fails the vertical line test, so no, this is not a function. Okay, use the graph given below to find f of -50. So for this one, -50 is your x value. Go to -50 on the x-axis. Go up or down until you hit the graph. So we're looking at this point. And what we want to know is the y value that goes with it, which we're counting by tens here, it looks like. So the y value that goes with this would be 30. All right, and this concludes the lecture for section 1.2.